In today's note, we're going to be looking at an introduction to geometrical relationships. Or in other words, we're going to be looking at an introduction to angles and triangles and some of the properties of them. So just to start off, think about all the things that you already know about angles and triangles, things that you may have learned in elementary school. If you can't think of anything, that's okay, because this note is going to look at a review some of the stuff that we should already know. And again, if not, that's okay because you'll be relearning it again now. So we're going to look over some key terms and things that we should already know. At first, an angle is the space between two intersecting lines. So if we look at our diagram over here to the right, if I have a line here, the color is thin to make it a little bit easier. So I have these two blue lines and they're intersecting. This space in between them that I'm coloring in red, this is your angle. Acute angles are less than 90 degrees. Obtuse angles are greater than 90 degrees. A right angle, we've talked about this with perpendicular lines. A right angle is an angle of 90 degrees. A straight line or a straight angle is 180 degrees. So whenever you see a straight line, it has to be 180. Reflex angle is an angle between 180 and 360 degrees. If you have 360 degrees, you have a circle or a full angle. Two types of angles or two that we can look at. One is a complementary angle, and these are two angles with a sum of 90 degrees. And something you can use to help you figure that out. Complementary, you can think of the C that represents a corner, and a corner is what a right angle symbol looks like, with that the two lines intersecting with the square. And the second type of angles are supplementary angles, and these are two angles that have a sum of 180 degrees. And again, a little trick to help you remember, supplementary, the S, you can think of straight line. And we know a straight line has to be 180 degrees. So when writing angles or when looking at angles, they're often written as 3 points, or we use 3 points to define an angle, with the middle letter being the vertex, and the other two are on the arms. Basically, as long as your vertex or the point is your middle letter, the order does not matter. It can also be written as just the vertex, as long as it's clear what angle you're referring to. So if I look at example 1, I have angle A and A and C representing the arms, and B represents the vertex. So those are my 3 points, A, B, and C. Because I want to represent the angle between the two lines, I would have to write it as either angle ABC, with B being the middle, or CBA, again with B being in the middle, or I could just write it as angle B, because here it's clear which angle I'm looking at. There's only one angle. So let's look at example 2, and let's try to label all the angles displayed below. So the first one we're going to do is we're going to look at this angle here. Now, I have points A, C, and B. Now, I could say this is angle C, but if I look at all my other angles that are being represented, C is that middle point. So I can't say angle C because I don't know which angle I'd be referring to. So in this case, if I'm looking at the red angle, this could be angle ACB or angle BCA. Basically what you're doing is you're following the line. So we start at B, go to C, and go to A. For my next angle, we'll use this right angle here. Again, I can't just say it's angle C because it could be any of these angles. So I'm going to use the 3-point system. So I have angle start at the end of one arm, B, C, D, Or if I go in the other direction, angle DCB. The main thing is that the middle letter is that vertex. Next example, we'll do this angle here. So if I pick a point or an arm to start on, we'll go E to C to D. So that would be angle ECD. Or if I went in the other direction, it'd be angle DCE. And lastly, I'm going to look at this angle here. So here I'd be looking at from E to C to A. So this would be angle ECA. Or if I went in the other direction, angle ACE. Now the biggest thing that you want to use this for is basically if questions are asking you to find a specific angle, you know what angle you're looking for. So what we want to look at next are the angle relationships of a triangle. So the main one that we should know is that the sum of all interior angles in a triangle is 180 degrees. And basically the interior angle, interior just means inside. So the inside angles of a triangle all add up to 180 degrees. So let's try to find the missing angles. Example A is already done for you. So that means if I look at this triangle, I have two angles that I know and one unknown angle. So that means that 76 plus the angle of 62 plus the unknown angle has to equal 180. 76 plus 62 equals 138. So that means that 138 plus my unknown angle has to equal 180. So to figure out my unknown angle, I do 180 minus 138, and I get 42 degrees. So let's try to use that same idea with example B. So I know because it's a triangle, they all have to add up to 180. So looking at this, I know that I have one angle that's 139, and I know I have another angle that's 23. So altogether, my two angles add up to 162 degrees. So that means to find my leftover angle, I have to do 180 minus 162, which works out to 18 degrees. So therefore, my missing angle is 18 degrees. For angle C, same idea. I'm going to take the two angles that I know, 63 degrees plus 72 degrees, and this works out to 135 degrees. So in total, with those two angles adding up to 135, I just have to find the difference from 180. So 180 minus 135 equals 45. So that means that my unknown angle here is 45 degrees. The next thing we're going to look at are the exterior angles of a triangle. So interior was inside, exterior is outside. So what we want to do first is look at these two statements just to help us understand our next property. So if A plus B equals 180 and B plus C plus D also equals 180, what can we say about the relationship between A and C and D? Well, if I look at these two relationships, A plus B equals 180, and then I have B plus C plus D also equals 180, and I did color code this specifically for a reason. If I look at the two, they're basically the same except for one thing. The C and D is different from this A. That's the only difference between the two. So that means that if everything else is the same except for A and C and D, they both equal 180, and B is the same in both, what that means is that the relationship between A and C and D is that if A plus B equals 180 and B plus C plus D equals 180, then A is equal to C plus D. So that means angle C and D is equal to angle A. And that is what our exterior angle theorem is. So what this theorem is that an exterior angle of a triangle is equal to the sum of the two remote or non-adjacent interior angles. So if I look at this triangle here, triangle D, and I'll color code this, so triangle D, or sorry, angle D here is equal to the two non-adjacent, or the two angles that are not beside it on the inside of the triangle. So that means I have angle A here and angle C, which is here. So these two angles, the one in the blue and the purple, is equal to angle D, which is the one in yellow. The second exterior angle theorem, so the second theory looking at exterior angles, is that the sum of exterior angles is 360 degrees. So if you remember, exterior means outside. So all of the outside angles, so in this case, this angle here, this angle here, and this angle here, they all add up to 360 degrees. So those are the two exterior angles theorems that we have to worry about when dealing with triangles. So, moving into just a last question, EQAO practice. So here we want to solve for A. So we're given a triangle and we're given what the three angles are. We know that one angle is A, we know the other angle is 2A, and we know the other angle is 3A. So here's what we need to know. We have three angles, they all have A, and we should know from a triangle that all three angles have to add up to 180 degrees. Now we need to solve for A. So now we have an equation. And this one is going to work out to be a simple equation. The first thing we can do is collect like terms. Because they all have the A value, or A variable, these are all like terms, so I can add all of these together. A, or 1A, plus 2A plus 3A equals 6A, and that all works out to 180 degrees. So 6A, or 6 times something, equals 180. To figure out what that something is, or to solve this equation, we're going to divide both sides by 6, and A equals 30. So we now know what A is. And another extension of this question usually might be, what is the measure of each angle? In which case we take this value of A and plug it back in to each angle. So A just equals 30, 3A equals 3 times 30, which equals 90, and 2A, 2 times 30, or sorry, 2A equals 2 times 30, which equals 60. So that is what the measure of each angle is. So the main thing we should get from this note is reviewing the key terms about angles, and then looking at the interior angle theorem, which is that they all add up to 180, and the two exterior angle theorems, where an exterior angle is equal to the sum, or you add the two non-adjacent, so the two angles on the inside that are across from it, and it should equal the exterior angle, and that all the exterior angles of a triangle add up to 360 degrees.